His main research area includes processing and wireless sensor network, etc. Now, I am requesting to you, sir. Sir, please share your expertise with us.
Thank you, Akanksha.
Thank you, sir.
So, good morning, all of the participants and my dear colleague.
Good morning, sir.
Before I start, I would like to know something from your side.
Namaskar, sir. I joined a bit late. Namaste, sir. I am Indu.
Good morning, ma'am. Good morning.
कैसे हो सर आप?
एकदम अच्छे मैम. आप सब अच्छे हैं?
हाँ अच्छा है सर अच्छा.
Okay, okay. So, before I start, I just want to take feedback from the participants. Since this is the last day of the workshop, so you might be knowing a lot of things about WSN and IoT. So before I start about routing in wireless sensor network, let me know how can you differentiate IoT and WSN. Any one of you please come forward. All of the participants are requested to contribute, please. How can you differentiate IoT and WSN? Or how these two things are different or are going to integrate with each other?
Good morning, sir.
Good morning.
Yeah, it is just WSN plus internet becomes IoT.
Is there, can you differentiate between the two? How IoT can be different from WSN or one and the same thing? What do you think?
WSN is a part of IoT, but IoT cannot be a part of a WSN. That's a
Okay, you can say WSN.
Good morning, sir. This is Dr. Supriya. And actually, sir, in the IoT, all the nodes, or we can say the smart devices, they are directly connected to the internet. But in the case of wireless sensor network, sometimes they are connected to a central server, and then they will connect to the internet.
Okay, so we can say WSN can be thought of as a subset
Yes, sir.
of IoT.
Yes, sir.
So one thing is this. Another thing conveyed by another participant is that, okay. So what about connectivity in WSN and IoT regarding connectivity?
IoT is directly connected to the internet, but in the case of WSN, connected to some kind of central server, and then they will connect to the internet. Like
Okay.
all the WSN
So we can
devices.
say in WSN, so in connectivity through, we can say IP address. In case of IoT,
Yes, sir.
and what about WSN? Do we have any IP address associated with each and every sensor node?
It is there, but first they will connect to the central node. So they will assign some IP address to that central node, and that central node is connected to the devices.
So we can expect no unique address,
Yes, sir.
unique IP address
I guess, sir. Yeah.
for every node. Not necessary. Most of the
True.
time not. Is it so?
Yes, sir. Yes, sir.
Yes, sir.
So what about routing? In case of IoT, when we talk about IoT, Internet of Things, do we talk about routing? Or
Yes.
routing is different in case of IoT, different from the Internet protocol?
Yes, sir.
How come?
Actually, the internet protocols are specifically works on the traditional networking TCP/IP protocol, But in case of IoT or WSN, they
No,
are
in case of
low
IoT
power
only.
and lossy networks.
No, in case
So
of IoT only, when a device is a part of an IoT, it is having an unique IP address.
yes,
It can communicate with all of the devices which are having IP address, unique IP address. So a communication can be there between different devices on the net through internet,
yes.
right? So is there any separate protocol for IoT?
Yeah, there is a standard protocol that is routing or low power and lossy network, that is RPL, uh,
Okay, that
which
is
is,
customized as per the need of the IoT.
yeah,
Okay. Okay. Thank you very much.
yes,
So,
yes.
anything say, any other wants to add? So, routing in case of WSN, that is going to be, of course, different. In case of WSN, we know not all of the nodes are having a unique IP address. They are not going to communicate through internet, right? So they have to communicate in different way. They have to provide their information and they have to receive their control information from different sensors in different way. So when we talk about routing in WSN, that is going to be a little bit difficult, primarily because of WSN is resource limited. So because in WSN, each and every node in the net is connected through wireless medium, right? Or we can say the nodes cannot be accessible at each and every moment. That means whatever resources you provide to a node in the WSN is going to be limited. So the mostly concerned resource is battery. So when this node is working, it has to collect, it has to gather, it has to sense data. It has to manipulate this data and communicate to the desired node. So in this process, that battery is going to deplete, right? So there are a number of constraints we can say that is going to impact lifetime. So WSN is going to work okay unless all of the nodes are working okay. All of the nodes are working okay until unless their batteries are giving enough energy, right? So we expect because the battery is a limited resource, so it is going to exhaust after some time. So depending upon that, the node may go down or may be out of the network or may not be working at all. So we can define lifetime of the network accordingly. So first thing is a limited resources like memory, computation, and battery power. So these limited resources, so because of battery, the lifetime is limited. Right? So battery is going to play an important role in deciding the lifetime.
Sir, your slides are not changing actually. We are on the first slide itself.
Okay.
Can you click on the fourth slide, I think? We're on the
Just wait.
Yes, now we can see lifetime constraints impacting lifetime, right?
Okay. Now you can see there are certain constraints that could cause the limited lifetime. So those are battery, computation power, and memory. We can say So this battery power is going to play an important role in the lifetime of WSN, right? So this is because of limited resources. Another is the communication medium. Communication medium is, we can say, not favorable at all. The wireless medium is very harsh for communication purpose. So we can say this is not favorable at all. We are going to face fading problem frequently. So because of this, the path loss exponent may be 3 or 4. Right? Or we can say very lossy. So communication from one node to another is going to consume more energy because of this wireless medium for communication. So at the first instance, we are having limited battery. Another instance is the communication medium is not favorable, very lossy. Right? Another thing is coverage and connectivity. Right? A particular node can cover a limited area. Right? So depending upon that coverage, if we want to increase the coverage of the sensor node, what will happen? We have to incur more battery power to cover more area. So we have to keep the coverage area limited, right? To save the battery energy. In the similar way, the connectivity means to connect with some another node, right? And the distance should be as minimum as possible to spend less energy, to spend less battery power. So coverage and connectivity is another issue. Another constraint is mobility. If node is stationary, then it's okay. It is to be configured one and for all. But if the node is mobile, then each and every time the node is to be configured, it is to be decided at which location the node is there, right? And in this process, we have to spend a lot of energy, right? So mobile node creates more problem or cause less lifetime. Another is QoS requirement, quality of service. How much latency the network can tolerate, right? Let us say how much latency. So if there are multiple nodes contributing in communication, then more latency would be there, right? So we can say latency, how much throughput we need, right? Information is in bursty nature or in continuous nature, likewise. So there are certain QoS requirements which are going to burden these limited resources further. And the last one is fault tolerance. Fault tolerance, we can say, when a particular node is not working or its battery depletes, then it should be possible that other nearby nodes take over or cover the particular target area, right? So fault tolerance means if a node fails, then nearby nodes should be able to cover the target area. So we can say because of sensor nodes are being sensor nodes in WSN are being deployed in most of the cases in inaccessible terrain. So it is not possible to replace their batteries. So we have to adjust with limited resources or limited battery life, and we have to improve the WSN life by devising certain efficient routing protocol. Now, can you see the next slide, lifetime maximization approaches? Is it visible? Lifetime
No,
maximization.
no, no, sir, no, sir. Sir,
Okay.
you just click on that. Now we can see, sir. We can see now.
So we have to concentrate upon battery energy of every sensor node, and we have to devise certain protocols so that the battery can last longer, or the WSN can work for more number of rounds of communication. So here we are going to talk about different approaches which are used to maximize the lifetime other than routing. So first of all is resource allocation using cross-layer design. So we know in case of sensor node has to gather data through physical sensing. So if physical layer has to be there, then it has to communicate with another nodes or base station, right? So it is should be having some second layer, that is data link layer or medium access control layer. It has to route the data through certain nodes up to base station. There should be some routing or network layer. So we can say a particular node may be having at least 3 layers: physical layer, right? Medium access control layer, network layer. So every layer is going to consume certain energy of the battery, right? For collection of data, physical layer has to spend some energy. For medium access control, the second layer has to deplete some energy, and so on. So we know that all of the layers are not supposed to work at all of the time, right? Let us say the sensor is sensing the data. It is not having data to communicate. It is sensing, right? So medium access or network layer can be put behind, or maybe may not be allowed to use energy of the battery, because
Hello.
I'm sorry,
Hello.
because of some power failure at my end.
Okay, okay, okay. No issues.
I'm going to log in with the help of my mobile. So until unless I got the power back on my desktop, let me continue with this mobile only.
Okay,
So
sir.
I think yeah. Okay, okay. So within a few seconds, I'm going to switch over to my desktop again. So we have been talking about cross-layer resource allocation. Cross-layer means one layer, for example, let us say, mm, let us say the sensor node is having some data to transmit, but the routing information is not there, or the sensor is working towards an efficient routing. In the meanwhile, the other layers may be asked to go in inactive mode, so they do not consume energy. So while designing a routing protocol, this cross-layer approach can be kept in mind.
Hello, sir. You can share slides to me. I'll present.
No issue. I just power is restored now.
Okay, okay,
I'm
fine.
switching over to desktop
Right,
within a
right.
short while.
Okay, fine, sir.
Okay, sorry for interruption because of power failure. So let us resume, continue our previous with our previous slide. Okay, you can see resource allocation using cross-layer design. So we can say when the one layer is working, other layers can be sent in active mode so as to save the power. So this is about first approach. Right. Another is opportunistic transmission. We know the transmission is through wireless medium, which is highly unfavorable. So we can say because so because of this fading, the environment is not going to support the communication continuously. Sometimes the environment or wireless medium is most favorable and sometimes it's not. So opportunistic transmission means that sensor is having some data but not transmitting. It is going to transmit it only when the medium is favorable, right? So in that way it has to spend less transmit power. So the sensor or the base station has to continuously monitor the fading pattern of the wireless medium, and accordingly it can direct the sensor nodes to transmit opportunistically. Another thing is that we can employ mobile relay or mobile sync. Let us say this is node, this is sync, right? So this node has to communicate through this node always, right? So this node is going to deplete its battery at very fast pace. So if it is if this sync is allowed to move, right? If this sync is made mobile, then sometimes sync will be here. Then this node has to communicate with some another node. So rather than burdening a single node, a few nodes in the network, the mobile sync can cause the node to transmit through different nodes. That's in that way the particular nodes are not depleting with their battery at very fast rate. So mobile relays or mobile syncs may be used for maximization of lifetime. Another is optical deployment of coverage connectivity, right? That means to cover a particular area, right? More number of nodes can be deployed, but what can happen? Redundant nodes may be there. That means few nodes may be covering a given target area. So same area is being covered by more number of nodes, redundancy would be there. So we can avoid redundancy by deploying less number of nodes, or we can close down, or we can put some nodes within the same coverage area. We can put the same nodes in sleep mode, right? So the coverage can be there, but extra nodes are sent to the sleep mode so that they can be used when the particular node is going to die. Data gathering, or you can say data aggregation. If at a particular cluster head or a particular node, it is decided whether the information being sent to the base station is redundant or not. So a particular node may gather data from the proximity nodes
and can decide whether the information is redundant or not, and it will provide some coding to compress the data. So compression of data will cause less transmission, less time of transmission, so battery saving would be there, right? So data correlation is also exploited in this aggregation or compression technique. Another thing is energy harvesting. So this is of course very good for uh, charging the battery of sensor nodes. So energy harvesting may be through solar, EM energy, light energy, which is nothing but solar energy. So energy harvesting approaches can be used with the sensors. So sensor may be equipped with some kind of solar cell or some kind of piezoelectric material to sense the vibration in the environment and get it recharged, right? So this is another approach to charge the battery of the node and increase the lifetime of the sensor network. Beamforming is another approach where rather than transmitting in all of the directions, few nodes are going to cooperate with each other in order to transmit the information in desired direction or in the direction of base station, thereby saving energy. Right? And the last but not least, the efficient routing or clustering. Right? So this is going to be there every time. Efficient routing, that means routing of the information from one node to another node, then finally to base station. How it is done so as to consume, so as to allow consume less energy of the battery. So we are going to touch upon certain clustering or routing algorithms. So we can categorize routing protocols in basically three broad categories: flag-based, hierarchical-based, and location-based. So in flash-based routing protocol, what we have to do? We have to, the first is sensor protocol for information negotiation. In this, rather than transmitting data, the metadata is transmitted, right? So in flag-based routing protocol, we can say one node can transmit from itself to another node, then finally to base station, right? So here the metadata is sent, not the original data. So metadata is very, very small in number, we can say. So the metadata is sent and requested for desired data, right? So here the base station is going to direct the node, or base station is going to flag the query. What kind of enforcement does it need? Accordingly, the particular sensor or particular group of sensor is going to transmit data to the base station. So base station is sending queries, or in another case, when that sensor node is having information, in case of if a base station is not sending queries, then what may happen? A particular node may be having some data to transmit, then it will flood that particular information in the network, and that information will reach to the base station.
So rather than waiting for queries from the base station, whenever a node is having some information, it will send it to the base station. So this is another way to save the energy, because, and this is good as far as number of events is less than queries, right? That means the sensor is having less information, or not frequent information. In that case, this routing is efficient. Another is minimum cost forwarding algorithm. So in this case, the least cost path can be acquired. As you can see here, from source to sink, certain paths are devised, and that path is given the name minimum cost forwarding path, right? Where the latency or throughput or energy requirement are minimum. Another category is location based. In this location based protocols, sensor nodes are addressed based on their location. That means the WSN or base station may be requiring certain information from certain part of the covered area, right? In that case, the base station is going to address a particular group of sensors which are covering those desired location. And node localization can be done via GPS or some other coordination methods. So there are certain location-based routing. The first one is geographical adaptive fidelity, where the complete covered area is divided into zones, and only one node is awake in each zone. Right? As I have told earlier, there may be more number of nodes covering the given or desired area. So we can allow certain nodes to go sleep. Right? In this way, we can save the energy and increase network lifetime. In second span, here coordinators are selected or groups are created, and coordinators takes the data from the nodes and convey it to the base station. Of course, this is not efficient. The third one is hierarchical based routing protocol. Here, two-layer routing is there, and the overall goal is to increase the lifetime of the WSN. Here, we can have higher energy nodes for transmission and lower energy nodes for sensing purpose. So this is of course not homogeneous WSN. So we will be concentrating on hierarchical based routing protocols, their concept. So in hierarchical routing, clustered architecture is there. Clustered architecture is there. That means, as you can see, this is base station, right? And these are different sensor nodes or cluster member. So this is made one cluster, this is another cluster, and a number of clusters are made out of the WSN. And one member or out of so many nodes, one node is declared cluster head, depending upon the energy with that particular node. So we can say CH cluster heads are chosen based on threshold value. That means it should be having certain energy above some threshold value. So leech is the basic protocol using this clustered architecture, and it was proposed long back. And this is the routing protocol where base station is fixed and sensor nodes are homogeneous, means all are having same level of energy or battery. So here energy conservation or energy efficiency is there because of aggregation and compression at CH. That means at CH level, at cluster head level, the data received from different nodes are aggregated so as to remove redundancy and compress so as to transmit less time, right? And this clustering is made adaptive. That means cluster head may be so in this leech low energy adaptive clustering hierarchy, the operation is like this. There are 3 phases per round. Advertisement. Advertisement means every node is to convey its battery energy and declare whether it has to it can participate in the cluster head election or not, right? So on the basis of this advertisement, the cluster heads are selected, then schedule is set up, and then data transmission is done, right? So this is periodic process. Before transmission of data from the sensor node, cluster is formed, cluster head is selected, then data transmission takes place, and again advertisement, then setup, then transmission state. So this is continuous process or periodic process we can see. So this is the phase, setup phase, select CH. CH selected through advertisement, receive acknowledgement, and a cluster is set up along with cluster head. Then transmission is done, right? Receive data from different nodes of the cluster, then aggregate data, compress data, transmit data, right? So this is first round. In second round, again setup phase, then transmission phase, and so on. So whenever a node or a cluster is having some data to communicate to base station, then it has to go through setup phase and transmission phase for every round of communication. So this is the scenario of different nodes in WSN. So here in case of leech, it is found that number of cluster heads is not restricted, right? Sometimes in case of 100 nodes scenario, sometimes number of cluster head may be 20, 30 out of 100 nodes. Sometimes it is less, sometimes it is more. So more number of cluster heads means more energy the node is going to consume, right? We can say more cluster heads, right? Cluster head has to communicate to base station. So cluster head spends energy faster than other nodes, right? So we want to keep the number of cluster heads to a certain value.
So cluster head depletes their energy quickly as they have to transmit to BS. Right? More number of CH means less time, less lifetime of WSN. So number of cluster heads is restricted to some percentage of alive nodes. So in leech, although there are a number of variants of the leech you can find in the literature, right? So all those variants are going to strike a trade-off between different requirements of QoS. For example, latency, throughput, mobility, etc. But more or less, in all those variants of the leech, the number of cluster head, there is no restriction on the number of cluster heads in the WSN. So here in this particular algorithm creep, the number of cluster heads is being restricted to some percentage of aligned nodes. So how much percentage would be better? So analysis has been done on total number of selected CH. So you can see 5% of total, 10%, 20%, 30%, no limit on the number of CH. So a comparative analysis has been done on to investigate the number of cluster heads on the lifetime of WSN. And it is found that when the number of cluster heads are 10% of alive nodes, then we can have maximum lifetime. The lifetime number of round of communications is maximum in case of when cluster heads, number of cluster heads is restricted to 10% of the alive nodes. So restriction on the number of cluster heads are going to make the leech protocol more efficient. Now further improvement we can incorporate. If you look at the scenario of WSN, this is a particular scenario where cluster heads have been declared. So this is, we can say, one cluster head, this is another cluster heads. So you can see in a particular area, only one cluster head, in the same area, more number of cluster heads, or we can say less number of member nodes, more number of member nodes, right? So to have a fair distribution of number of nodes within a cluster, it is proposed that the given area is be divided in different sectors. So you can see sectors are defined, right? And in each and every sector, only one node is allowed to become cluster head. So it may be possible that a particular sectors may be having more CH cluster heads, but CH with largest energy is allowed to work as CH. Node with the largest energy is allowed to work as CH. So one CH is selected from one sector. Another improvement we can bring in is that here we have defined
8 sectors for 80 live nodes. So as the time progresses, the number of live nodes are going to decrease, right? So when there are less number of nodes, less number of live nodes in WSN, then we are supposed to reduce number of sectors, number of clusters, number of cluster heads. So this is done like this. When there are left only 40 live nodes, then we divide the complete area in 4 sectors and 4 CHs are selected. So by keeping the number of cluster heads to a minimum value, we have been able to save the energy and increase the lifetime of the network, WSN. So this analysis has been done on this basis, right? Then further, to improve this particular algorithm further, it has been decided that if nodes are within a certain range, then they can communicate to BS directly. They need not to be part of a cluster, right? So we can say this is the range where the sensor nodes are going to communicate with base station directly. They are not going to be a part of any cluster. They have not to report to any cluster head. They are communicating directly to base station, right? So in this way, these nodes are communicating with single hop, so there will be less delay from information transmission. So when this particular improvement is included, then we can have further improvement in the lifetime of the network. So this is about cluster-based architecture. We can make a number of improvement. So moving the improving the basic routing algorithm like leech and other algorithms, or you can customize those routing algorithm as per the need of the application in end. So of course you have seen that this WSN nodes within the WSN are different from IoT. They are not having any IP address. They are not communicating through internet. They have to organize within themselves, right, to make clusters, and clusters are made adaptive to make them consume less energy and enhance their lifetime. So overall goal of the routing protocol is to provide more lifetime to the WSN. So we have talked about a number of improvement on the leech and have seen the different way to move towards the efficient routing within WSN through hierarchical method. So this is all about the routing protocols in WSN. If you have any queries or any point to discuss, please let me know.
Participants, you can ask questions from sir.
Excuse me, sir.
Yes.
So then how we can differentiate the routing in WSN and in IoT?
In WSN, internet has nothing to do. In WSN, specific, right? In WSN, the medium is wireless for communication. In case of internet, the medium may be or may not be wireless, but each and every device in IoT is having unique IP address, and it has to communicate through internet. Right? There is no internet in the WSN. The network or nodes within WSN has to organize within themselves, has to communicate efficiently to the base station. Base station may further have gateway
Okay.
to connect with internet.
Yes.
So we can say WSN is a subset of IoT.
Yes, sir.
Right?
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Okay. Any other, please?
Any other questions? Okay, I don't think, sir, there is one question in the chat box.
Let me see. What is the maximum number of nodes a cluster head could control in a particular cluster? No. Actually, we cannot say there is a maximum number of nodes a cluster can control. Generally, what we prefer, as we have discussed or investigated, if there are 10% of cluster heads, let us say we are having 100 nodes within WSN. So we prefer there should be 10 clusters or 10 cluster head. So on average, we can say a cluster head is supposed to communicate or control 10 nodes. Right? It can be more, it can be less, but that can be at the cost of the energy of the network or at the cost of lifetime of the network. Right? So as per our investigation, we can declare, okay, there can be a 10% of the total nodes a particular cluster head has to control. I could only, I could
Yes,
see
sir,
only
only.
one query within chat.
Yes, sir. Yes, sir. Akanksha, you there? I think there is no other
Yes,
question.
ma'am.